Hello, good evening everyone. My name's Ryan Young, I'm an integration architect with Open Answers. Just in case you haven't heard of Open Answers before, there's a quick slide there with a few of the services we offer and the customers that we work with. We're a MuleSoft partner, and one of our MuleSoft customers is NHS Blood and Transplant, and that's going to be the topic of discussion today. We're engaged by NHS Blood and Transplant to design and develop an API that is used to integrate a new mobile application that's been developed by the NHS with the organ donor register. And so yeah, a bit of a project intro. So back in September 2017, the Health Secretary announced that a new NHS app will be built offering 7 key functions such as making GP appointments, ordering repeat prescriptions, and one of those core functions will allow app users to register their organ donation decision on the NHS organ donor register. So the NHS app to organ donor register integration was implemented in two to three phases. We had a so-called MVP phase where we reused the existing fire and forget web form that can be found at organdonation.nhs.uk. That provides the ability to create and update a registration on the organ donor register, but you can't retrieve it. It's a fire and forget flat file based interface. It works, but there wasn't a great user experience because you need to fill out the form. You need to enter in your name, address, date of birth, etc., all of which is already contained within the app. So yeah, it wasn't a great user experience, but got them up and running very quickly. And then phase 2 was the real-time integration using the FHIR-based REST APIs. So this provides full CRUD capability, including the ability to retrieve your organ donor decision in addition to the create and update. We're using industry standard-based interface specification, so the FHIR standard, which I'll come on to in more detail in a later slide. Much better user experience because the forms are pre-populated. All you have to do is register your decision, and yeah, so it's a better way of doing things really. So yeah, so I mentioned so the ability to recall amends. This was requested specifically by number 10 Downing Street and the Department of Health and Social Care in support of a legislative change. So the law is changing in England. So currently there's an opt-in system where you in order to become an organ donor, you need to register on the organ donor register. And the law is changing in 2020 next year, where we move to an opt-out system where by default everyone is an organ donor unless you previously opted out or you're in an excluded group. And so the ability to be able to recall and amend your organ donor decision through this app was really seen as a key enabler for that legislative change. So yeah, so diving into the some more technical aspects of the API implementation. So yeah, so this is a high-level architectural view of the organ donor register before we did any integration with the NHS app. So we've got a big population database down here which holds all of the organ donor register records, about 25 million records or so, about a third of the population are currently registered. Sitting in front of that, we've got a portal application which is used for internal use. There's various internal teams that use the portal in order to view records within the register and also update them. And then we've got a number of feeds coming in from various third parties, so DVLA boots provide options to register your organ donation decision. We've also got the organ donation website, which is this guy over here. And these third parties and the website are basically generating XML files which get dropped onto an SFTP server. And then there's a batch process which runs over here, which picks up those XML files and ingests them into the database. And yeah, so here we have the MVP phase. So we've got the NHS app over here, NHS app user, which is, as I say, just plugging into the existing organ donation website, just wrapping that web form in a sort of an optimized way. But again, that's just dropping files onto the SFTP server, fire and forget, and those files are then ingested into the database. And then finally, we've got the full real-time integration with using MuleSoft. So we designed and developed what we call a FHIR API, which I'll come on to in the next slide. This is essentially a REST API that's called from the NHS app, which talks down to a SOAP API on the back end here, which is based on the XML schema that's used for the flat file interface. So we've got some reuse of that, reuse of the schema, but also reuse of some of the business logic that sits in the database for ingesting that data. And yeah, so this is basically an implementation of the REST mullet integration pattern. So we've got business on the front, REST JSON, body on the back, SOAP XML. So yeah, a bit about the HL7 FHIR standard, for those of you not familiar with it. So FHIR stands for Fast Healthcare Interoperability Resources. And it's essentially a combination of two things. It's a resource-based content model, a data model, combined with real-time RESTful interface specification. It's developed by HL7, who are a standards developing organisation, been around for a while, since 1987, and FHIR is essentially the latest in a long line of standards that they've developed. This is just drilling down into an example FHIR resource content model. So here we've got a screenshot of the FHIR website. We've got a number of resources there, and here we've clicked on the patient resource, which has revealed the resource content down here. So you've got all the usual sorts of things that you might expect, name, gender, birth date, address, and so on. And these are essentially properties on this resource. They're a mixture of simple and complex types. As you might expect, you get each property has a cardinality, has a data type, and descriptions and constraints associated with each of those fields. And here I've just, as an example, just clicked on one of the complex types, the address field, which takes me down into this guy over here. And here, as you can see, it's more of the same, but all the things you might expect: city, district, state, postal code, etc. So I think it's fair to say that the NHS are really putting their weight behind the FHIR standard. So this is mixed from a recently published NHS Digital Data and Technology Standards Framework. So there are a total of 10 sort of headline standards within this framework. And in at number 7, we've got all NHS digital data and technology services should support FHIR-based APIs to enable the delivery of seamless care across organisational boundaries. So the NHS are really getting into FHIR in a big way. If you want to know more about FHIR, you can visit the FHIR website there. There's also a number of helpful videos on YouTube. And search for FHIR intro. The NHS are also working on some FHIR implementations themselves with sort of varying degrees of security. So the NHS Care Connect API and the NHS GP Connect API. So both of those are publicly available. They're hosted on GitHub, as you can see. So you can go and take a look at those. And the final point there is that if you're an Anypoint platform user, you can go and search for FHIR Accelerator on Anypoint Exchange, which is exactly what I've done here. So this is a screenshot of the public Anypoint Exchange. So these are a number of assets that have been provided by MuleSoft. So the first 4 here, we've got some RAML specifications. So the MuleSoft have basically taken the FHIR standard and developed a number of RAML specifications based on that. So example implementations. We've also got some templates, which are essentially implemented flows using the APIs up here. And we've got a number of API fragments. So what they've done is they've taken the RAML data types and converted those into API spec fragments, RAML fragments, which can then be reused in your API specs. And here I've clicked on the first result in that list. So this is the Healthcare Accelerator. So this was really useful when we came to design this API. The FHIR spec is pretty complex. There's quite a lot to it. So to see a real sort of concrete implementation of the of FHIR within RAML, so it's written in our target interface specification language. So this is really useful. So you can see there we've got a number of resources down the left-hand side here, with sub-resources hanging off those. And they're also they're reporting a number of dependencies, these are the RAML fragments down here that basically used to build the data model that sits behind the API. And so here we have a screenshot of the actual organ donor register FHIR API that we developed. So we've got a couple of resources. We've got an organ donation registration resource. We've basically got CRUD operations hanging off that. So we've got create, update, withdraw, delete, and a lookup an organ donation registration. And then the final resource down here is to retrieve some reference data, which is used to drive some of the forms within the NHS app. And so we've essentially built this on top of a number of the data types that we were able to retrieve from Anypoint Exchange, from the stuff that MuleSoft worked on, and it really sort of kick-started our design. So yes, here's a quick pie chart which illustrates the sort of reuse of RAML data types. So the big section in blue is the RAML data types that we're able to reuse from endpoint exchange. It wasn't complete. So they've provided examples, but we had to add a few more of our own, which is that small orange section there. And we also had to extend a few of the existing data types to get them to work exactly as we wanted. So yeah, so a few words of caution on RAML reuse. So it's great to be able to reuse stuff that other people have done and import those into your project. But make sure they're well documented. So all of your properties should be properly described using a description element, and make sure they're secure. So don't leave any holes in your API. Review all of those properties and make sure that you're not allowing any things that you shouldn't be. And yeah, final point there. So yeah, don't be afraid to extend RAML fragments as required. So yes, this is a bit of a look, a drill down into how we've converted the FHIR spec into RAML. So this is the standard HSM FHIR spec that I showed you earlier. So it's the address data type with all the fields there. And this is what MuleSoft have provided straight out of the box. So you can see that it's not, they're kind of similar. Obviously you've got the list of properties, you've got the cardinality in there through the question marks, you've got the data types. There's a few things missing, I guess. The descriptions are certainly missing. And so this is where we have essentially extended that address data type. So we've got here a new data type called registrant address, which is subtyped from the address data type that was provided by MuleSoft. And we've gone in, we've augmented that with descriptions for each of the fields, and we've also added a new address line data type, which is this guy down here, where we're validating the data that's received, making sure that we don't receive any attack vectors, so cross-site scripting, that sort of thing. So we're making sure that we don't allow chevrons and JavaScript constructs, that sort of thing. So key takeaways from the API implementation. So the HL7 FHIR standard it is complex. There's quite a lot to it. There's a lot of online documentation to digest, but certainly the endpoint exchange accelerator really helps to sort of visualize the standard and see it working. There's certainly a lot of out-of-box data types. I mean, HL7 really know what they're doing. They've been doing it for a long time, as you'd expect. And so, everything that we needed was pretty much there. So that was really good. And final point there is that the NHS have really put their weight behind it. So if you work in the healthcare industry, you really need to take note. And the second point there is that endpoint exchange provides plenty of API specs and examples that can really help to accelerate your design. However, as I mentioned earlier, you need to make sure that the RAML examples are fit for purpose, that they're secure, that you're not having holes into your API that could be exploited potentially, and that they're sort of well documented. Don't be afraid to extend those RAML fragments. And the final point there, probably the most important point of the whole presentation, is that once you've productionized those RAML fragments and you've security tested them, they've been hardened and tried and tested, you can then republish them in endpoint exchange and reuse them to drive future projects ahead. And finally, the NHS app is available on iOS and Android, so you can download it right now from the App Store and Google Play, and go ahead and register your organ donation decision.